Can you solve this weird looking question? Now here we have symbols, double exclamation, hash and exclamation as a prefix. But each of these symbols have specific meanings in mathematics. So this is 9 double factorial upon 7 primorial times 5 subfactorial. How do we solve this? So let us understand the meanings of these symbols. So first, let's talk about the factorials. Factorials denoted by n exclamation. It is the product of all positive integers from 1 to n. So if we have 4 factorial, this is equal to 1 times 2 times 3 times 4. 5 factorial is 1 times 2 times 3 times 4 times 5. So from 1 till n, where n is 5 or n is 4. So this is called factorial. Then we have double factorial denoted by n double factorials. It is the product of all the integers from n down to 1 that have the same parity, odd or even as n. That means if we have n as an odd number, then n factorial will be equal to product of all the odd numbers till 1. If n is an even number, then product of all the even numbers. Let me give you an example. If we have 4 double factorial, then it is equal to 2 times 4, because the even numbers between 1 and 4 is only 2 and 4, 2 numbers, so it is equal to 8. 8 double factorial will be 2 times 4 times 6 times 8. So you write the product of 8 double factorial. What if we have n as an odd number? For example, 5 double factorial, it is equal to 1 times 3 times 5. All the odd numbers between 1 and 5. So this is called double factorial. Then we have primorials denoted by this hash sign. It is the product of all prime numbers less than or equal to p. So if we have p hash sign, that means product of all the prime numbers which is less than or equal to p. So if we have 7 hash or 7 primorial, then it is equal to product of all the prime numbers 1 times 3 times 5 times 7. If we have 8 primorial, then all the prime numbers from 1 to 8 is 1 times 3 times 5 times 7. 8 is not a prime number, so we are not going to take that. So we have to take the product of all prime numbers less than or equal to p. Here it is equal to p because 7 is also a prime number. Here we are taking less than 8 because 8 is not a prime number, so we are just taking till 7. Then we have the subfactorial denoted by the prefix of exclamation denoted as factorial n. It counts the number of derangements of n distinct objects, that is the number of ways to rearrange them so that no element appears in its original position. Now suppose that you have 3 items A, B, C. In how many ways you can arrange these items so that each of them are at different positions? So first we will fix A and change the positions of B and C. So it will be C, B. Then fix the position of B and write A, C. Again fix the position of B, shuffle C and A. So it is B, C, A. Then fix the position of C at the first place. Change the position of A and B. Again fix the position of C and change the position of B and A. So you can see we can arrange 3 items in 6 different ways. So we calculate it using the 3 factorial. 3 factorial is 1 times 2 times 3 equals to 6. So using 3 factorial, we can calculate how many ways we can arrange these 3 items. Now we have to arrange these three items in such a way that none of the item is at its original position. Now we can cancel the arrangements in which A is at the first position. So this is the original position. We cancel any other arrangement in which A is at its first position, so we cancel this. Next, we cancel any other arrangement in which B is at the second place, so we cancel this also. Third, we cancel any other arrangement in which C is at the third place, so we cancel this. So there are only two ways that three items can be arranged so that none of them are at their original position. This is called derangement. How do we calculate it using formula? So first we write 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial multiplied by 3 factorial. 3 items means 3 subfactorial. We have to arrange 3 items. So 3 factorial, 1 upon 0 factorial, value is 1. 0 factorial equals to 1. By convention, 0 factorial is equal to 1. 1 factorial equals to 1 plus 1 upon 2 factorial equals to 1 upon 2 minus 1 upon 3 factorial is 1 equal to 1 upon 6. So this and this gets cancelled. So 3 factorial, get the LCM, it will be 6. 6 divided by 2 is 3 minus 1. Now 3 factorial is 6. 3 minus 1 is 2 upon 6. So 6 and 6 gets cancelled. So answer is 2. So you see two ways that three items can be deranged, and we calculate it using this formula. Now 9 double factorial equals to product of all the odd numbers. So 1 times 3 times 5 times 7 times 9 upon 7 primorial is product of all the prime numbers. Prime numbers till 7 is 1 times 2 times 3 times 5 times 7. Now we can cancel the like factors here. So this is equal to 9 upon 2. Now 5 subfactorial. Let's calculate using the formula. So 5 factorial times 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial, or 5 factorial equals to 1 times 2 times 3 times 4 times 5 equals to 120. We can write it now or use it later on. So we can write 120 here, 120 here. 1 upon 0 factorial equals to 1 minus 1 upon 1 factorial equals to 1 plus 1 upon 2 factorial means 1 upon 2 minus 1 upon 6 plus again 4 factorial equals to 1 times 2 times 3 times 4 equals to 24. So we write 1 upon 24 minus 5 factorial is 1 upon 120, or equals to, we can cancel this 1 and 1. Now let's take out the LCM. The largest number is 120 and 120 is divisible by all these numbers. So LCM will be 120. So 60 minus 20 plus 5 minus 1, or 120 times 60 minus 20 is 40. 40 plus 5 is 45. 45 minus 1 is 44 upon 120, or equal to 120 times 44 upon 120. So we cancel this. So this is equal to 44. So 5 subfactorial is equal to 44. So 9 upon 2 times 44. Divide 44 by 2. 9 times 22 is 198. So answer is equal to 198. I hope it was easy. I hope it was easy to understand. Thanks for watching.